Excellent immersed MBR module. Its essence lies in working under lower transmembrane pressure. XMBR, Tubular Array Membrane, is a new patent design MBR module. The first feature of it is the extremely lower transmembrane pressure. XMBR is likely the lowest transmembrane pressure running module in the world. The flow path structure inside one piece of tubular array membrane element is 0.4 micrometer pore of PTFE hydrophilic film with 200 parallel lines of tubes arrayed on the inner side base plate, each of 5 millimeters width. Internal the film and tubes, and along two sides of the tubes. There are numerous tiny distributing holes of 1 millimeter water assembling holes. The permeated water pass through the film, and ranks of water distributing holes flow over to tubes, go horizontally and parallel into the water vertical channels at two side edges. Each channel has 3 produced water outlets of 25 millimeter diameter. Pieces of membrane elements overlying construct the membrane module. Produced water outlets intercoupling form 6 groups of purified water passage. Converge water to the confluence water pipe of 50 millimeters at 4 corners. Compare with XMBR. Hollow fiber membrane or other flat sheet membrane require higher transmembrane pressure when working. As everyone knows, the higher the TMP, the bigger the permeate flux. What if the permeate flux is the same, but the TMP is higher? Thus can only illustrate this membrane or membrane element and/or membrane module has higher resistance to the water flow. The sectional permeate flux maldistributed. Partly the flux is higher and partly is lower. It shows gradient distribution. On the contrary, the lower the TMP, the more even the flux distribution. We know that the operation must work at critical flux. Due to the hollow fiber's diameter is too tiny, along the length direction, the permeate water to unit membrane area is certainly not even, and the previous flat sheet membrane normally has 1 or 2 nozzles of water flow path. The nozzle's diameter is restrained by the frameboard's thickness. The nozzle not only limits the water effluence, but causes the permeate flux nearby extremely higher, even higher than the critical flux, whilst the flux at far distance decrease gradually, and the furthest corner from the nozzle could possibly have no water filtrated. Due to the permeate flux maldistributed, clogging often happens at the nearest place around nozzle of membrane element. At this area, the membrane is working at overcritical flux. The earliest clogging to hollow fiber happens at the root of fiber connecting to water effluence pipe, whilst the earliest clogging to flat sheet membrane happens at the nozzle's nearest place. Afterwards, constant permeability operation will drive the clogging area swiftly enlarged and extended. After part of area is fouled, effective filtrate area is reduced. To ensure its flux constant, it can only increase the permeate flux from the other section to make the compensation. Therefore, these phenomena of working upon overcritical flux and uneven flux distribution become even serious, and then more rapid fouling comes, until to bring a disaster of membrane fouling accident. By the creative design, XMBR owns gradually enlarged effluence path and extremely lower resistance loss, working under lower transmembrane pressure. Having solved the above-mentioned difficult problems, XMBR is less possible to cause fouling on membrane and can keep stable filtration operation. Meanwhile, because of its sectional permeate flux is even, the working area of membrane is nearly equal to its installed flux. The average flux value can be taken higher, or the aeration intensity value could be taken lower. Now let us learn XMBR's actual operation through a design case study. This is an MBR system treating oily wastewater of 4,320 tonnages daily, adopting 60 sets of XMBR modules. Installed inside 6 tanks, 10 modules in each tank. Every 5 sets of XMBR 200 is connected to a produced water pipe, towards to a TMP tank, and 12 TMP tanks, produced water convergence to a confluence pipe. Each set of XMBR 200's other 2 joints will connect to cleaning return flow pipe. This pipe eventually leads to the cleaning tank. When XMBR is working, TMP level control valve can be adjusted to define the transmembrane pressure. The operation relies and only relies on the drive of transmembrane pressure, which can drive mixture in the tank, permeate across the membrane, entering into effluence path inside XMBR, and then produced water flow, along with the produced water pipe, into TMP tank, and then to the confluence pipe. When MBR requires cleaning in sight, produced water valve turned off, TMP tank at higher liquid level, and the cleaning pump sends the prepared cleaning liquid from cleaning tank to TMP tank. Relatively, a level difference is formed between XMBR tank and TMP tank. The liquid flow into XMBR, scour membrane surface, soak and dissolve the membrane pores, and then permeate through the membrane. The remaining cleaning liquid return to cleaning tank through the pipe, and cleaning pump implements stronger recycle washing. The above equipment has overcome various disadvantages. A previous industrial wastewater treatment MBR system has ensured the system's stable and durable operation for long term. Cebu Company owns rich experiences in project practices. XMBR tubular array flat sheet membrane is created and enhanced from quantities of practices and lessons. It is a type of MBR module with higher permeate flux, lower energy consumption, and higher stability in working.